Oftentimes people will approach a particular chapter in our text, and as they page through it, they see this sea of formulas and examples and so on, and it may not be clear to them, well, what am I supposed to come away with from this particular chapter or this particular section? And so I just wanted to mention very briefly, because we don't cover everything in every single chapter, right? There's certain things that we omit. There's other things that we emphasize particularly heavily. And I think that comes through in the syllabus and in the assignments and so on. But if you're looking for sort of a starting point, you can find at the very back of each of the chapters a list of objectives. And so if you're looking for some kind of a laundry list where you can check off, I've done that, and I've done that, and I've done that, and so on, not a bad thing to look at. These are also repeated in the start of each of the sections. So anyway, that's definitely something to look at. Now in this video, we're going to talk about measures of central tendency and dispersion. And so we have a few examples, and we're going to look at the calculator and so on. Let's cut to the chase here. Now the first thing I want to mention, before I forget, we have this formula card here. If you have a hard copy of the text, it may be included as part of the end papers. And if not, you can download a PDF version of this from MyLab and Mastering. It's under the Tools for Success tab that you see at the left when you're in there navigating around. As you can see, I'm logged into MyLab and Mastering right here, and I have clicked on that Tools for Success tab, and you'll notice right here under Review there's the formula table card. And so if you're looking for a PDF of that, here's where you'd find it. Now we have copies of this formula card on reserve in the Math and Science Center, so that if you're taking an exam and you want to have the formula card, all you have to do is request it. And we appreciate it, of course, that you return it as well. But anyway, the thing that I'm trying to get across here is that when you look at this formula card, it should be clear that since we're allowing you to have access to it, we're not really expecting you to memorize all these formulas. And I'm saying that now because in this section that we're about to start, measures of central tendency, there's a fair number of formulas that come up. And so this is something that people always look at. And in the past, there's been people who have fixated on the formulas to their detriment. So even though we want you to know how to find these formulas and how to use them if necessary, reality is that we have other ideas about this. And so that's what we want to make clear in the video here. So we're going to start with what we call measures of central tendency. And by that we mean, or we are referring to, rather, that's probably a poor choice of words, mean, median, and mode. Now most people know mean, but not necessarily using that term. They would refer to it as an average. And the reason that we don't use average is because it is a little bit ambiguous. Once you understand that there are different measures of central tendency, and average is used to indicate a measure of central tendency, you understand that it's vague, and so for that reason we try to be a little bit more specific. And so if we're looking for a particular measure of central tendency, we will tell you mean, median, or mode. So you can read the definitions of those for yourself in the text. As far as what they represent on a practical level, it's just like the title says, they are measures of central tendency, meaning we use those to find the middle of a data set. And so something else that we want you to know, aside from the definition and where to find them on the formula card, would be how do you find them using a calculator. And so let's talk about that. We'll show you an example here. I think it's always best to start with an example, and so we're going to use the one that you can see on the screen in front of you right now, number 26, which is titled Old Faithful. Now something to notice, Sullivan has a propensity for repeating data sets. So in other words, if you page through this particular part of the text, you're going to find this data set repeated in a couple of sections. And so for that reason, when you're working on a particular problem in Sullivan or on MyLab and Mastering, it's always a good call to kind of check ahead a little bit and make sure that that data set is not going to be reused before you delete it. So in other words, you can save yourself a little bit of hassle if you make that check. You'll otherwise find yourself repeating data sets and having to retype and retype and retype and retype. All right, anyway, number 26 says, we have all heard of the Old Faithful geyser in Yellowstone National Park. However, there's another less famous Old Faithful geyser in Calistoga, California. The following data represents the length of eruption in seconds for a random sample of eruptions of the California Old Faithful. And so they are asking then in the question here, it says, determine the shape of the distribution of the length of eruption by drawing a frequency histogram. Find the mean and the median. Which measure of central tendency best describes the length of eruption? So obviously, we're going to have to key in that data into the calculator. So let's do that. So as you know, for any kind of a data-driven problem, you're going to be keying in data using the stat menu, and you're going to use the edit menu to get it into a list. I'm going to clear my lists. I always do that before I start some kind of a problem. I just want to make sure that I don't have any artifact data hanging around, and it turns out that I do actually. So I definitely would not want to have that contaminating what I'm doing right now. So anyway, go back to stat. I'm going to clear list, and in this case we only need one list, so I'm just going to do it like that. You could have cleared it individually inside the list as well. And so now we want to key this data in. So I'll go back to the stat menu, I'll press enter, and I'm ready to start keying in. If you want to follow along on your own calculator, I'm going to have the problem on the screen here in a second, and you could follow along and key it in yourself and get everything that we're going to get, whatever seems good to you. So here's the problem, and when I show you my calculator the next time, I will have this all keyed in. Okay, everything's keyed in, and you can look at the problem in the text and see that there are 44 observations, and my calculator is waiting for number 45, so I have them all in. So let's see again what we're supposed to be doing here. The instructions say to determine the shape of the distribution of length of eruption by drawing a frequency histogram. Find the mean and the median. Which measure of central tendency best describes the length of eruption? Okay. So with regard to the histogram, one of the things we want to get across is that bin width is an important choice, but there is no single correct bin width. Especially in this case, they haven't said anything about, what we should be using as classes or class width or anything like that. So it's always a good call in this case to look at a few different bin widths and see which one seems to be the best. So let's go to the calculator and get a few different snapshots of this data set. So if you recall, in order to get the calculator to cough up a histogram, you have your data keyed in, and you want to quit this, and then you're going to go to a stat plot. Now it happens that I have one turned on already, and I also have the histogram selected. So in other words, you need to make sure that the stat plot is on. You can see that the on right there is inverted, and the one that's flashing right now is the one that you want. And so as long as you have all that selected, then you're good to go. Now this typically defaults to list 1, at least it will right now. And as far as the rest of the entries, like the frequency, don't mess with that, just leave it as 1, and you're ready to generate this now. So let me quit this, and I'm gonna get the window sized right. So if you remember, we have a nice feature here called Zoom 9, which is a zoom stat. And what that does is it looks at the data set and it gives you a reasonably sized window with everything displayed for you, and then you can tweak that or customize it as needed. So there's my histogram, and I'm kind of curious what we have in terms of a window size here, so I'm looking. Now, this works together to a certain extent. So in other words, the 90 and the 5, the 90 is the lowest value, it's the lower limit of the first class, and the 5 is the bin width, if you recall. And so you can see that everything works here for that. If you're going to make some changes, you probably want to kind of change everything all at once. And so a little bit of experience will help. But yeah, I'm thinking, I don't know, let's make a few changes here. I think that the histogram looks okay. I mean, let's take a look at it again here. It's got, let's see, 1, 2, 3, 4, 5, 6, 7 classes. That's a good number. But I'm kind of wondering, well, what would happen if we went with a more finer bin width, like say 4? Would that help us out here? So you can just make the change right here. You can start at 90 if you want. The calculator generally defaults to the smallest data value, so that's a fine choice. And then if you change that to 4 and you graph it, you'll notice that it changes the appearance slightly. And so it looks like we still have, no, we have 8. We have 8 classes now that cover it. And so how would it look with 3? I don't know. Let's find out. So I'll go down here and I'll pick 3. And then I'll graph it. Yeah, it gives me a little bit more detail. So I can see some gaps there like that. I think that, just for my sense of it, it looked the best when we were using a bin width of 4. You might want to try a wider bin and see if that gives you something worth looking at. I think that actually 4 is probably the best choice. So I'm going to stick with that. It gives me a reasonable display of the distribution, and I can see everything I need. So I don't really think I need to tweak the window size any further. So they were asking us to get this, and so you could draw it if you wanted or something. Typically, if you have this kind of a problem in MyLab, they are going to give you a multiple choice version of it. So you kind of pick the one that looks the most like the one you have on your calculator screen, and generally that should be sufficient. Let's see what else the problem was asking for. So as you can see, we're fielding a multi-part question here, and so we want to make sure we answer all the parts. So the first thing they're asking is that we would determine the shape of the distribution by drawing a frequency histogram. And so if I was answering that, I would say, well, remember we had showed you before kind of a template, 4 different distributions, and we're wondering which of these 4 distributions comes closest to what we saw on the screen. So that template would be here. And so it's definitely not uniformly distributed like you see in figure A. And so I would say it's between B, C, and D. Bell-shaped, skewed right, skewed left. And so if we take a look at the calculator, I would say, well, it looks kind of bell-shaped to me, wouldn't you say? I mean, it's not perfect, but it's approximately bell-shaped. That's probably a safe answer. So I think I'm going to go with that. I'll put that down in a minute. Let's look at the rest of the question here. The next thing they ask is that we would find the mean and the median. So we're going to use the calculator for that. So I want to get out of here, and I'm going to go back to the Stat menu, and I'm going to use the right arrow key to go to the Calc submenu. And the function that I would use is the one that's selected right there, number 1, the so-called one variable stats. Now this one defaults to list 1 if you don't supply an argument, especially if you're using an older TI-83. So if you don't have list 1, it's going to have to be told what list the data is in. So I'll show you the syntax of the command in a minute. Anyway, let's select it. Just press enter. Now my calculator has this cut and paste interface. And so you can see it's asking, hey, list 1. Yep. So you can press enter to affirm that. For the frequency list, you don't want to have anything in there. So you just have to press enter and then press enter again. Now you saw for a brief second there the command on the screen. And so if you're using a TI-83 and you don't have list 1, for example, let me go back and show you the command there. The list name can be changed. So all you'd have to do is edit the list, whatever list your data is in. But I'm in list 1, so I'm good. So go back to that. So here's pretty much everything I need. They were asking for the mean and the median. And so the mean is up here at the top, X bar, sample mean. And there's a rounding rule that applies for mean and median. You're allowed 1 place beyond what the data contains. So in other words, if you go back and you look at the problem in the text, all of the data here is integer valued. And so that would mean that when you report the mean or the median, you would report it to the 10th place. That would be the correct rounding in this case. And so if I was answering this question, my calculator is telling me that the mean is 104 point, and I would just 104.1. And if you're looking for the median, you have to scroll down a little bit. You'll notice right there it says MED is 104, so that would be your median. And so then you would write that down as well. Now in this case, the median is an integer value because if you know the definition, it's the middle of the data set. And we have an even number of data values here, so we took a calculation to obtain it. But anyway, the median is 104, and so you don't have to add a decimal to that. You can just report it as 104. And so I'll write that down in a second. Let's see what else the question is asking. It says, what measure of central tendency better describes the length of eruption? Okay, so I think I know what I'm being asked here, and I'm gonna write down an answer for you. So in response, regarding the shape, as we said, it was approximately bell-shaped. The mean is x bar, and that is 104.1. The median is 104. And as far as which of the measures of central tendency is best, we're hoping you're going to notice that they're practically the same as we would expect, because this is a bell-shaped distribution. So in other words, we're figuring that you've seen this. And so in other words, as you'll notice in the middle of the figure here, figure part B of figure 6, when you have a bell-shaped distribution, even approximately bell-shaped, we would expect that the mean and the median basically agree, as you see here. And so regarding which one is the best one for locating the central tendency, I would say, well, it's kind of a toss-up. On one hand, it's definitely true that probably more people know what a mean is without having an explanation needed. Whereas if you say, oh, it's the median, it's quite possible that a good number of folks would not know the median. So, you have to decide on this one. I would say 6 of one, half a dozen of another. Since they are the same, either one would be a reasonable choice. Now, I want to suggest something. I hope you noticed that when I was fielding this example, not once did I actually reference a formula off the formula sheet. I was using my calculator, and our expectation is that you would do the same. We have you getting a graphing calculator for a reason, and so it would be ridiculous if we didn't ask you to use it. Anyway, you're going to see that this data set is repeated. We have another video where we're going to look at the measures of dispersion in connection with this. But before we do that, we have a couple of other things to say about measures of central tendency. So just to recap, again, mean, median, mode. These are measures of central tendency. Mean and median are used with quantitative data. Mode is used with qualitative data. And it's entirely possible that a data set would not have a mode. But you can read about that in the text. As far as finding them on the calculator, as we showed, you're going to be using the stat calc submenu. And as far as the rounding rules, both the mean and the median are rounded to one place beyond what the data reflects. So if your data has 3 places, for example, you would round your mean or your median to 4 places. If it had 2 places, you'd go to 3 places, and so on and so forth. Now, the very last thing we want to get to is resistance. And so one of the concepts we expect you to pick up as you go through this section is that some statistics are resistant and some are not. And resistance refers to the sensitivity of the statistic to the presence of outliers. So, in other words, in this section, you can read that the mean is not resistant, but the median is resistant. So, in other words, the mean can be influenced by an outlier much more easily than the median can. And so if you're looking for some kind of a thought experiment that would illustrate this, you can imagine a classroom full of people, and we calculate their net worth. And so we come up with a certain figure. Net worth is what you own minus what you owe. And then we had someone come to visit us, like Jeff Bezos, the owner of Amazon.com, or the CEO of Amazon.com, not really the owner, or say Bill Gates or Warren Buffett, or someone who's famously wealthy like that. And then we repeat. So in other words, before they come into the room, we calculate mean and median net worth. And then after they come in the room, we calculate mean and median net worth. And what we're suggesting here is that because the mean is not resistant, the presence of Bill Gates or Warren Buffett or Jeff Bezos in a room of middle-class people, that's going to have a huge impact on the mean net worth. Whereas the median net worth is going to be practically unchanged. And so that's what we mean by resistance, and I would encourage you to make sure you read about that a little bit more in the text. Please feel free, go on to the next video, and if you have any questions about this one, drop me a line.